So here I'm talking about the traditional ARP. I told you in our switching environment, when PC1 wants to communicate with the PC2, it uses a kind of broadcast, which is traditional ARP. So if I can show you, like it is written here, traditional ARP. What is ARP? Both the ARP probes and the ARP announcement are sent as a broadcast, which is nothing but what? All F. Using the destination MAC address FFF in the Ethernet header. Because it has learned about the source MAC, the switch has learned about the source MAC address because it was coming from the some MAC address like AAA. So when it will hit the switch, it knows that source MAC has AAA. So it will add this into CAM table, but it has no idea about the destination MAC. So let's suppose we have multiple computers here connected. And this wants to communicate with this PC, which has, let's say, BB MAC. It has idea about AAA, but does not know about the BBB because the communication is happening using what? IP, IPv4. They know each other about the IPs, but they are not familiar with the MAC addresses. And the switch will learn the MAC address and it has no idea about the destination MAC address. So it will flood everywhere with the help of what? Traditional ARP, which is doing what? Broadcasting this MAC address FFF everywhere. Just like if you remember in the DHCP, we do the broadcast having 255.255.255. So in a switching environment, we use concept all Fs and it will hit every computer on the same subnet. But with the help of IPv4, if this source has an intention to reach this IPv4 address of this computer is gonna receive and read that packet. So as soon it will receive that packet, it will know that, yeah, this computer is looking for me. So I'm gonna send back a reply. So once it will send back the reply will have this MAC address now. And the switch will add this into the CAM table for the future use. So next time when this want to communicate with this one, now CAM table is already populated and now it will be forward directly without sending broadcast. So if I can show you this in this image or the animation, basically what is happening. So this host A wants to communicate with the IP 10.0.0.22, which is host B. As I told you, these host machines have information about the IPs only. They don't know about the MAC addresses of each other. So that is the reason ARP is used to find out the MAC addresses. So it is saying if there is someone out there with the IP address 10.0.22, please send me your MAC. Here is my MAC. So what it will do, it will flood everywhere to the server, to this host B, even this router as well. But these two will discard because as you can see, I'm looking for 10.0.0.22, not 33, not 99. So this one will receive and now it is going to reply back. So it is saying I am 10.0.0.22 and this is my MAC address. So now this time host A will receive and now host A ARP MAC table, because every computer also have this ARP table as well. Now this ARP table will be populated with this MAC address of this host B. So next time when this host A wants to communicate with host B, this is already having the information about the MAC address of host B. So it will communicate directly. So this is known as traditional ARP.
And having this type of information in switches, sometimes you work with the engineers, they can actually track down machines once they have this information right down around. Like they can say,
Yes,
this
yes,
MAC, give me the MAC address of this machine. You'll go to ipconfig/all, and you're gonna have that MAC address. You're gonna have that's the MAC address of this machine, and they're going to tell you exactly where this machine is on which switch, basically, which port exactly as well.
yes.
And if you are doing this job, then of course, at some point you're gonna go into a switch and you'll find these MAC addresses associated with the ports and the machines IP addresses.
Yeah. So since we are here, I'm going to discuss about the security concept of that is regarding ARP as well. That, you know, if you have heard about Mac off from the Linux machine, if you type from the Linux command prompt, you can flood a million and trillions of MAC addresses. What will happen? I'm just going to give you a scenario. Well, let's say we have this switch and it has ability to save only 100 MAC addresses. Okay. And let's say it has only 10 devices. So CAM table is only flooded with 10 uh, devices information with a MAC address. So what the evil devices or the hackers they do, from the Linux machine, they will run this macof command, which is basically going to flood this CAM table. If it has a capacity of saving 100 MAC addresses, it will send like million and trillions of MAC addresses in a just fraction of second. And just imagine what will happen to the CAM table of this switch. It will be like over flooded.
Is that like a DDoS attack?
Yes, you can correlate with that one. Like it has flooded with so many CAM tables. Now it is full. This CAM table is full. So now what will happen? This switch will now work like a hub. So you can now connect any device with this switch anytime, and it will communicate with anyone. Okay.
No
So
way.
now this switch, because it is now over flooded with MAC addresses, and now this switch has no any kind of intelligence at all, in short. So whatever now attacker want to do, he can do. Okay.